Two types of gear. The gear has been classified through a lot of methods. The classification that is most popular is through the different position of the gear axis. Another way is through method of manufacturing, material and tooth profile. This time we introduce the methods through different position of gear axis and manufacturing. Classifications by the position of gear axis. 1. Parallel axis gear, the teeth are parallel to axis. A. Spur gear. This is cylindrical gear. Tooth trace is parallel to axis. This is a highly demanded gear, which is easy to manufacture and to assemble. B. Helical gear. This is a cylindrical gear. Tooth trace has helix curve. Helical gear provides more strength, less oscillation and lower noise level compared with spur gears. However, helical gear provides a thrust load to axis direction. If changed rotating direction, thrust load is reversed. C. Internal gear. This is a cylindrical gear ring with teeth formed at the inner diameter. The most popular demand for internal gears is used for mechanism of planetary gear train. There are two types of tooth trace, one is parallel and the other is helix to axis. However, gear with parallel axis has higher demand. D. Straight rack. It is thought that radius of spur gear grew infinite to become a straight line. It can be matched with spur gear to convert between the rectilinear motion and the rotary motion. E. Helical rack. It is thought that radius of helical gear grew infinite to become a straight line and tooth trace is also straight line. It can be matched with helical gear to convert between the rectilinear motion and the rotary motion. F. Double helical gear. The shape looks like two helical gear joined together. Therefore, this type of gear does not have thrust load to axis during operation. Other types of gear designs used for parallel axis such as non-circular gear and eccentricity gear are available but omitted this time. 2. Intersecting axis gear. G. Straight bevel, miter gear. This is gear with tooth trace, which is a straight line in the same direction as surface element of pitch cone. Miter gear has shaft angle of 90 degrees and gear ratio of 1:1. H. Angular straight bevel gear. Angular straight bevel gear which does not have shaft angle of 90 degrees. I. Spiral bevel gear. Tooth trace is described as a curve with spiral angle. Spiral bevel gear has advantage over straight bevel gear for gear strength, oscillation and noise level. Disadvantage of spiral bevel gear is axial thrust load. Therefore, proper bearing location and firm support are needed. J. Angular spiral bevel gear. Angular spiral bevel gear does not have shaft angle of 90 degrees. K. Zero bevel gear. This is zero bevel gear, similar to spiral bevel gear with zero spiral angle. The tooth trace is described as a curve with spiral angle of 0 degree. Occasionally, spiral angle 10 degrees or below are also called zero bevel gear. The force of tooth action is the same as straight bevel gear. L. Face gear is face gear. A tooth disc gear can be matched with spur or helical gear. There are two types of face gear with shaft angle 90 degrees, intersecting axis and non-intersecting axis. 3. Skew gear, non-intersected gear. M. Cylindrical worm gear. This is a worm gear pair consisting of cylindrical worm gear and worm wheel. Meaning of cylindrical worm gear is that the thread has one or more starts. This worm gear pair provides high speed reducing ratio and low noise level. Disadvantages are low efficiency and generation of heat. N. Crossed helical gear, screw gear. This is a gear pair for transmission between non-parallel and non-intersecting axes of cylindrical gears. Is pair of helical or spur gear. Due to spot contact in theory, design of transmission should be light load. O. Hypoid gear. This is a gear for transmission between non-parallel and non-intersecting axis of conical gear. This gear is similar to spiral bevel gear. Most popular usage is for differential gear for automotive. Others including enveloping worm, spheroid and helicon gear types of gear designs are available for non-parallel and non-intersecting axis but omit at this time. 4. Machine elements compared with gear for similar shape and purpose of usage. P. Sprockets. This is sprocket wheel used for matching with bush chain and ladder chains. Usage is for transmitting a power over long distances between axes. R. Ratchet gear. This is ratchet gear, which looks like the teeth of saw formed at external wheel used for positioning, index, ing, and preventing inversion. S. Timing pulley. This is timing pulley using matching timing belt with teeth. Usage is for transmitting power over long distance between axes.